Okay, so here we have a problem involving a bend reducer, and we're asked to determine the discharge, the pressure and velocity at section 2, and the x and y forces that the bend exerts on the water. In this problem statement, we're given that there are no free jets and that the bend is in the horizontal plane. So this means that the pressure at 1 and 2 is not assumed to be 0, and the horizontal plane part means that the z components in the Bernoulli equation are equal, so we can pretty much just ignore them for now. So for part A, we're asked to determine the discharge, and we know the velocity and the diameter at point 1, so we can simply use Q equals V1A1 in this situation. And V1 is given as 8 feet per second, and A1 is pi over 4 times the diameter, which is 6 over 12. Remember to keep everything in feet or in inches, just make sure it's consistent, and the diameter squared. So we have that, and we get Q to equal 1.57 cubic feet per second. And that's all there is for part A. So for part B, we're asked to find the velocity and the pressure at point 2. So again, we know the area and we know the discharge now, so we can find the velocity. So we have Q equals V2A2 now, and we know Q, which is 1.57, which is going to be equal to V2, which is what we're looking to find, times the area at 2, which is pi over 4 times the diameter in feet squared, and we get V2 to equal 23.5 feet per second. So half of part B is done. Now we are asked to find the pressure at section 2. Now to do this, we use the Bernoulli equation. So H1 equals H2, and we have P1 over gamma plus Z1 plus V1 squared over 2G equals P2 over gamma plus Z2 plus V2 squared over 2G. We know P1 is given in the problem here as 2 PSIG, so we need to make sure to convert that to PSFG. So we have P1 over gamma plus Z1, which is 0 because this is in the horizontal plane. We have V1 as 8 given in the problem, squared over 2 times G, which is equal to P2, which is what we're trying to find there, and then over gamma plus Z2, which is 0, plus V2 squared, which we found previously as 23.5, over 2G. And if you solve all this out, we get a value for P2 being negative 185 PSFG. So that's part B done. Now we get into the more confusing and a little bit tougher part of this problem, and that is to find the x and y forces exerted on the bend. Now to do this, we're going to split this problem basically in half, or this part in half, and we're going to deal with the x components completely separate, and we're going to deal with the y components completely separate. So if we'll remember the equation for the momentum, which is the sum of the forces, and we'll just go with the x direction first, is equal to sum of the m dot out in the x direction times the velocity in the x direction out minus sum of the m x in times the velocity x in. So there's our equation, and if you'll recall, m dot is equal to rho q, which is 1.94. That's the value of rho in water. That's the density of water, times q, which we found earlier to be 1.57 cubic feet per second. So m dot is going to be equal to 3.05, and the units of m dot are slugs per cubic foot. So we have our free body diagram shown here. This is something you would have to do, but it was given in the answer key. So we have the forces in the x direction. This y component will not be there, but we have the x component of the force exerted on the water, which is what we're trying to find eventually. And we have P2A2 and P1A1, and then we have to make sure to account for only the x portion of those. So we have the sum of the forces. We'll assume that right on this diagram here is positive, and we have negative f of x plus P1A1 times cosine of 42, and then minus P2A2 times the cosine of 30 degrees, which is equal to m dot, which is 3.05, times the velocity in the x direction coming out, which would be the velocity of v2 in the x direction, which is 23.5, times the cosine of 30 degrees, and that's minus m dot, the x component of v1, which is 8 cosine 42. And P1A1 is simply the pressure at 1 in feet per second in PSFG, which is given in the problem as 2 times 144 times the area of 1, which is pi over 4, times d squared, making sure units are consistent. And then P2A2 is equal to, we just found that in part B here, to be negative 185 times the area of 2, which is pi over 4, times the diameter of 2 squared, or the area of 2 squared. And we get these values for P1A1 and P2A2 to be 56.4 pounds for P1A1 and negative 12.4 pounds for P2A2. And we simply just plug these values into this equation here, and we'll see that our only unknown is f of x, which was what we were trying to find in this problem. So we eventually come out with f of x being 8.70 pounds facing the left. As you can see, this is facing the left right here, and that is half of part C completed. And we do the exact same thing in this entire problem, just with this equation here. We're pretty much just going to replace all the cosines of 42 degrees and 30 degrees with sines. So we'll do that now. We have sum of the forces in the y direction equals sum of the m dot y out vx out minus sum of the m dot y in v y in, and we just we use the free body diagram to find out what values we need for the sum of the forces. So we're going to have a positive Fy plus P1A1 sine 42 plus P2A2 sine 30. And that's the left side of the equation there. And then we have 3.05 for m dot, that doesn't change. And then the velocity coming out in the x direction, so the x component of v2, and v2 is 23.5 times sine 30 degrees minus 3.05 times the x component of v1, which is 8 times sine 42 degrees. And again, the P1A1s don't change, so we found those right here. And we will figure out that Fy is our only unknown. So we just algebraically solve this problem, and we get the value of Fy to be 83.6 pounds, and that is acting downward. Actually, we'll get a value of negative here, which means that the assumed direction in this problem is incorrect right here. So we'll get a negative number, and then so that means that this this force in the y direction is actually downward. And that is our problem completed. Hopefully this helped. We got a test on Friday for you guys, so hopefully this helps you guys prepare for it.